Hello, everyone. Welcome to the Gitlab 17.3 Outlook. My name is Sampath Ranasinghe. I'm the product manager for the group. So let's get started with the first item here, unified backups. With unified backups, we aim to create a single backup solution that works across all GitLab installations. Linux package, Docker, cloud native, hybrid, and source code. The reason for doing this is we currently have multiple backup solutions that for targeting each one of these different installation types, and it's quite confusing for our customers where they are each has a different set of capabilities and has different ways of invoking it as well. So the single backup solution will mean we have consistent experience for all of our customers across different types of distribution. It also means we can consolidate our work behind a single solution and get the efficiencies, engineering efficiencies from developing and maintaining a single solution. We also want to power the backups, have our backups power SaaS offerings. So that's GitLab Dedicated and Gitlab.com. This gives us opportunity to dog food the solution as well. Again, something that is not possible with the current solution. So the sub pieces of work related to unified backups that we'll be taking on in this milestone is finishing up the portable backup beta. What I mean by portable is we will use the native capabilities of the different services so that when the backup is taken, it can be restored to any platform. It's not vendor specific and it's not cloud vendor specific. As for example, if we were to take a backup of RDS using AWS, that backup is not portable. We cannot take it to, for example, GCP or Azure and try and restore it there. But with portable backups, the data is collected in a portable format that can be restored to any GitLab installation on any hosted platform. So we're going to look to finish that off. That is targeting 1K reference architectures only, and we'll get that out as a beta. This lays down the foundation for our next item here, which is the cloud-based backups for supporting 10K reference architectures, cloud-native reference architectures on GCP. So we've made some progress already on this front. We've been working on object storage backups, but we'll be adding Cloud SQL backups plus repository backups, and that will give us that'll take us towards backing up a 10K reference architecture on Google Cloud. Next up is Org Mover. Org Mover is a project that we are developing internally to be able to move organizations from one cell to another cell. Cells is the foundation for our next generation architecture for GitLab.com. It essentially shards the GitLab.com data across multiple infrastructure instances. And we need to be able to move organizations between cells, and the Org Mover will be facilitating that. The first step for Org Mover is to facilitate moving organizations from the current GitLab.com monolith to what we call secondary cells. So they're moving the organization from the monolith to the sharded architecture. So we made quite a bit of progress on this front. Lots of investigations have gone into it, and lots of de-risking and understanding of what the best approach is. So based on the research we've done so far, we've also been building a high-level blueprint for Org Mover. So we will continue to wrap up the blueprint based on our findings, and then move on to the actual implementation work. We start with making Geo, which is what Org Mover is based on, the Geo technology, underlying technology for replicating data from one cell to another cell. It's very similar to replicating data from one geosite to another geosite. So we'll be making that a Postgres replication agnostic. Why, you may ask, are we doing this? This is because Today's geo replication is based on streaming, Postgres streaming replication. Postgres streaming replication doesn't work so well when we want to move a subset of Postgres data to another location. This is where Postgres logical replication has been identified as the most suitable technology. So we want to make Geo's replication technology Postgres replication agnostic, technology agnostic. So we want to allow Geo to use either streaming replication or a logical replication. Now, however, we do have some complications with the current monolith. We are running into some wall disk I/O throughput saturation concerns if we were to add Postgres logical replication. So therefore, we're taking a slightly different approach when it comes to moving organizations from the monolith to a secondary cell. But longer term, logical replication will be the main workhorse for moving organizations between cells. Then lastly, from the main pieces of work that we'll be tackling in this milestone is updating our guidance for customers upgrading to Gitlab 2.28. There is some changes related to locale data when you go from Gitlab 2.27 or earlier to Gitlab 2.28 and later. Relatedly, we are also deprecating support for CentOS 7 in release 17.6. So any later operating systems will be supporting Gitlab 2.28, and we need to provide guidance for Geo customers on how best to manage this upgrade. The changes to locale data impact Postgres indexing, and it can corrupt those indexes. And Geo and GitLab and Geo itself both rely on these Postgres indexes. So we've already provided guidance for non-Geo installations, and we want to, in this milestone, Geo team, we want to provide guidance for how best to handle this when you have a Geo install in place. And then lastly, we have a couple of miscellaneous items, mainly bug fixes we want to get to in this milestone. That concludes GeoGroup 17.3 Outlook. Thank you for watching, and I look forward to seeing you next time.